treasure box.
How do we open it?
I think we have to do these problems.
Let's go inside and figure them out.
Okay.
Let's talk about the least squares regression line.
It is called the least squares regression line because it minimizes the variance or the sum of the squares of the errors.
For example, in the graph we have here, the LSRL is a line that makes the overall distance of each point from the line as small as possible.
It's basically the line of best fit for each of the data points given.
The least squares regression line is always in the form of y hat equals a plus bx. The a is the y-intercept and the b is the slope.
Here, a is the y-intercept, and we find this by substituting y hat in this equation for the mean of y, and x for x bar, which is the mean of x, and then just solve for the a, and you end up with a equals y bar minus bx bar.
We can find b by multiplying the correlation of the two variables r times the standard deviation of y over the standard deviation of x.
The least squares regression line is also used to predict a particular y value from a given x value. In most cases, the LSRL does not perfectly pass through each datum point as shown here. Therefore, we calculate the error between the predicted value and the actual value by subtracting our predicted y from our observed y. So our predicted y value here is 2, and our actual y value is 1. So therefore, the error is 2 minus 1, which is 1.
Those errors are actually called residuals. You can find it by the equation y minus y hat, which is observed minus predicted.
If you use an x value that is too far outside of this range, you are extrapolating and your prediction will not be accurate.
The least squares regression line can also be found using your graphing calculator. When you go and enter your values in list 1, that represents your x values. In list 2, those represent your y values.
Then press stat, then calc, then 8. The values of a, b, and r should then be visible.
Now, for examples. Our first example. An ecologist examined the relationship between the number of new birds, y, and the percent of returning birds, x, for 13 sparrowhawk colonies. The data is shown below. Now, part A says, enter the data into your calculator and make a scatter plot. For question A, we're going to enter the data into our calculator and make a scatter plot. So, first, we go to our calculator and we press stat. 1, edit. We already have our numbers in list 1 and list 2. Then you press second, y. You'll come to this screen. You'll press 1 and make sure in your x list is list 1 and your y list is list 2. Then you press zoom 9 and boom, a scatter plot. Wowza, and look at that, a regressional line. Now we once again get our handy dandy graphing calculator and we enter the equation into y1. Then you press zoom 9 and there it is. We got a nice looking regressional line.
C asks, explain in words what the slope and y-intercept of the regression line tells us. The slope of this LSRL tells us that when the percent of returning birds increases by 1, we can predict that the number of new birds will increase by 0.304, our slope. Then our y-intercept tells us that when the percent of returning birds is 0, which is right at the y-axis, we can expect 31.9 new adults to be in the colony. However, this is extrapolation. Remember, 0 is too far out of the range of the x values to be used, and that answer is not very accurate. Question 2 asks, some people think that the behavior of the stock market in January predicts its behavior for the rest of the year. Take the explanatory variable x to be the percent change in a stock market index in January, and the response variable y to be the change in the index for the entire year. We expect a positive correlation between x and y because the change during January contributes to the full year's change. Calculations from the data for an 18-year period gives x bar equals 1.75. S sub x equals 5.5. 0.36%. Y bar equals 9.07%. S sub y equals 15.35%. And R equals 0.596.
Part D asks, an ecologist used a line to predict how many birds will join another colony of sparrowhawks, to which 60% of the adults from the previous year return. What is the prediction? So to solve this question, you would have to plug in the 60% for the x. So you do y hat is equal to 31.934 minus 0.304 times 60%, which then gives you 13.66, which is approximately 14 new adults. So for number 2, part A, it asks to find the equation of the least squares regression line for predicting full year change from January change. Show your work. So for number 2, to find the y-intercept, you would do b is equal to r times s sub y over s sub x. And then you would plug in your values. So for r, you would plug in 0.596. For s sub y, you would plug in 15.35%. And for s sub x, you would plug in 5.36%. When you plug in your values, you would get 1.707 for b. So to find a, you would do y bar minus x bar times b. So you plug in your values and you get 9.07% minus x bar, which is 1.75%, times 1.707. So when you plug all the values into your calculator, you get a is equal to 6.083. So to find the equation of the least squares regression line, you would do y hat is equal to a, which is 6.083, plus b, 1.707x. And that's the equation of the least squares regression line.
For number 2, part B, the question says, the mean change in January is x bar equals 1.75. Use your regression line to predict the change in the index year in which the index rises 1.75 in January. Why could you have given this result without doing the calculations? Well, to figure out this question with the calculations, we would just have to plug in 1.75% as our x. Y hat is equal to 6.083 plus 1.707 times our x value that was given as 1.75%, which is then equal to 9.07%. Okay. The reason we don't need to do these calculations is because if you were to plug in x bar as into your equation for y hat, you would end up with y bar, which is already given in our equation, 9.07, which is exactly what you get when you do the calculations.
Yes, we finally finished the second question. Let's open this thing.
Yeah, we can open the second lock now.
Yay!
Are you guys ready for this?
I really don't know what's inside.
No way! The golden calculator.